Und du hast die Bühne.
Okay, danke für die Einladung hierher. Hallo, willkommen. I'll switch to English if that's okay with everyone. So my slides are in English, and in my field, computer science, English is the default language. But if you don't understand something, let me know. Switch or explain in German as well. So I want to talk today about knowledge acquisition from text and LLMs at scale. And I'm a computer scientist, so I'll offer, I think, a computer science perspective, which might be different from the way that you commonly do things, but I hope it's an interesting complement and enrichment. Yeah, I still have the old logo there. I see I need to update that. So I'm wearing two hats here. So on the one hand, I'm from TU Dresden, where I'm at the Faculty of Computer Science. At the other hand, I'm at this institution in the bottom left, SCATS.ai Dresden-Leipzig. So that's a National AI Research Center for foundational AI research, with locations in Leipzig and Dresden, which are both affiliated with universities. So in that sense, I'm part of this national center. And my location is not the main computer science building, if some of you know that, Nödnitzer Straße, but SCATS AI, so we are sitting there close to Hauptbahnhof, Strelner Straße, next to the EO hostel. So in a way, also closer to here than the Faculty of Computer Science. Yeah, I'm Professor for Knowledge Aware AI since June last year, so I still call myself new, but we just discussed I'm losing this bonus recently, so in administration it's usually helpful if you can say sorry, I didn't know. I'm new. Now before that I was at Bosch in Stuttgart, research scientist. Before that at the MPI for Informatics, Max Planck Institute, at the other end of Germany in Saarbrücken. And before that I spent 7 years in Italy, in Bozen, Bolzano, where I did my PhD. And at the very beginning I actually started here in Nödnitzer Straße. I have a diploma in computer science from TU Dresden. And today I want to talk about AI knowledge and AI knowledge acquisition. Introducing two pillars of AI knowledge, which are more the old-fashioned way, the knowledge graphs, and the modern way, the large language models, that I'm sure everyone's very familiar with, but I'll try to offer a complementary perspective from computer science. And then I want to talk in particular about common sense knowledge, which is, you could also call it everyday knowledge or basic knowledge or Weltwissen, so which is basic knowledge that humans have, that AI systems should possess, that to some degree they possess or sometimes not. And in particular, I want to introduce two approaches from my group. So Candle, which is about cultural common sense knowledge acquisition from text, and Mango, which is about cultural common sense knowledge from LLMs. And yeah, to start, what is AI knowledge? There's actually no straightforward definition. In particular, when you negate it, so what is AI without knowledge? It doesn't really make sense. So everyone working in AI needs to embed some kind of knowledge in AI models. So AI models always have some knowledge. But actually, when one digs a bit deeper, then one key point that emerges is AI knowledge refers to broad world knowledge. So for example, also chess computer has knowledge, but it's very specific to chess. Whereas when we talk about AI knowledge, we usually mean a common, a broad world knowledge, which is not for one specific task, but which covers the general world and can be used in different tasks. And so I'll focus on two pillars of AI world knowledge. On the one hand, knowledge graphs, abbreviated as KGs or KBs for knowledge bases, and the large language models, the LLMs. And to give you an illustration where these two types of AI knowledge are at play, we can go to web search engines. So this is actually what Google looked like 15 years ago. I don't remember it myself, but there are some websites which have archived the look. And we can very much see how AI knowledge plays a role there. So if you inserted in Google 15 years ago the question Kästner born where, you might have gotten a response like this. So in der Gemeinschaftspraxis Unterwellenborn hat jetzt Andrea Kästner, Kinderarztpraxis Unterwellenborn, and you can already guess why you get these results. There is actually Kästner here, which is one of my search terms. There's also Born here in the Unterwellenborn. but obviously that's not what I was searching for, right? So this is an example of a stupid AI system, or let's not even call AI, just a stupid IT system which doesn't possess world knowledge and therefore doesn't understand what I mean. So if you go to knowledge-aware AI today, so you might probably know what will be the response when I issue this to Google today. Kästner born where? So then I get a response like this. I directly get the answer here, and I get a supporting text snippet. And this illustrates nicely the two types of AI knowledge that I mentioned. So this part actually comes directly from Google's internal knowledge graph. They have a huge knowledge graph built up internally. So they're showing here that they disambiguated the meaning of Kästner. Kästner could mean many things. There are many people called Kästner. But they disambiguated that I'm most likely meaning Erich Kästner. And born, they disambiguated that I don't mean unter Wellenborn or something else, but born where refers to the relation place of birth. So these are two disambiguation steps. And then in the knowledge graph, once you have done this disambiguation, it's a simple lookup. So knowledge graph or database, it's just finding the right entity, the right relation, and then looking up the value in the database, knowledge base. So that's the knowledge graph at play. And then in the bottom, we see the other type of AI knowledge at play, so the large language models. So this is a text snippet, which is actually taken from Wikipedia, no surprise. Actually, the majority of Google results are fed by Wikipedia content. But for many years, it has been very complicated to process such text and find out answers. And this is what an LLM is excelling at. So here, the large language model identifies where in this text snippet is the answer to my question, and then highlights it. And therefore, gives me via two different modalities, the knowledge graph and the text, the desired information. And yeah, one can scale this further. For example, if I search for Kästner awards, I get a very nice structured result again. So, okay, Kästner probably means Erich Kästner. Then I get a structured listing of awards that he won, also the year that he won them, and here even for what his award is. So it's for doppelte Lotchen, 2 times Lotte. So all this is fed from the knowledge graph. And yeah, one way to visualize these pillars of AI knowledge are, so on the one hand we have the knowledge graphs, on the other hand we have the large language models. On the third hand, we have the web contents. On all these three are interrelated in many different ways. So, in particular, we're typically training the LLMs on web content. We're extracting knowledge graphs from web content. The LLMs can interface to knowledge graphs as tools or retrieval augmentation. Info boxes are typically fed from knowledge graphs and so on. So these are tightly interrelated. And yeah, please interrupt me when there are questions throughout. We want to wait till the end. Yes?
What is exactly knowledge graph? What can I think about?
You can also call it a database. So it's a structured representation of facts about the world. Actually, let me just go to this slide here. So what are knowledge graphs? So the most prominent knowledge graph is actually called Wikidata. It lives in the Wikimedia universe. It's the structured side of the Wikimedia universe. So Wikipedia is mostly about text. Wikidata is about structured so-called triples, which say Kästner, born Dresden, Kästner, birth date, this and that, Kästner, a child, so and so, Kästner, authored. So all the things which you can nicely express in a structured database triple. For example, libraries very much rely on this kind of data for the, you could also call it the hard facts about authors, for example.
And maybe you do not need or need of any categories. You do not have to say, okay, we need the place of birth, and we need a date of birth, or we need the parents, or something like this. You can extract all information about a person in a triple, and sort them in a knowledge network about, and you can ask, please show me all people that are were born in Dresden, for instance, or in January, or in Berlin, or visit Berlin at the same time. and that's a little bit better possibility to extract data and organize it. Yeah.
Yeah. Well, once you have structured questions, they are easy to answer over knowledge graph. They're not easy to answer over text or science fiction authors that were born in Dresden or whatever joins or combinations of facts you want to make. That's easy to do. Now, Wikidata is the most prominent one here. It's huge, so 110 million items, over 1 billion statements. There's a lot of data there, but knowledge graphs are far from perfect. So they capture nicely the hard facts, but the subjective and the verbose things they cannot capture. Yeah, they're extensively used in search, recommender systems, and so on. Also, commercial players use them a lot. So I showed the example of Google, where the result is fed by the knowledge graph. Normally, these commercial players are very secretive how they build these knowledge graphs, and they're using data from elsewhere and so on. But there are occasionally funny leaks. So here's an example. Siri, so Apple's assistant, suddenly told you that the national anthem of Bulgaria was Despacito. What happened actually in Wikidata? Someone did vandalism. Someone just changed the value Bulgaria national anthem to Despacito. And Apple was taking this data from Wikidata uncritically, importing it. You can still go to the edit history. So Wikimedia, Wikipedia, Wikidata, they all preserve the edit history. You can still trace this back to sometime in, I don't know what, 2016 or so, when someone made this fun vandalism there. So yeah, the commercial players benefit a lot from this data. Yeah. So much, just a very short intro to knowledge graphs. About LLMs, I don't want to say too much because I think all of you are very familiar with them. I just want to spend 2 slides on, let's say, the most over-the-top topics. So LLMs and human intelligence, that's a question that I hear often raised, and especially in popular media, there's this question, will LLMs take us over soon, and so on. From my computer science perspective is that LLM behavior is fascinating, and one has to be fair. So in AI, there's been a long history, 20, 30, 40 years, of trying to build intelligent applications via something called the more symbolic way or logical way, and it didn't really work well. And LLMs, conditioned on what limited track record we have, they're actually fascinating, that they're much more human-like in their simulated behavior than the traditional logic-based way. So there's quite some properties, so how they're latently clustering things, or how they perform step-by-step reasoning and so on, that are looking closer to human reasoning than the old way. And the paper, for example, which announced GPT-4, they call it sparks of artificial general intelligence. That's a big buzzword in the AI community, AGI, artificial general intelligence. I think it's not unfair to call it. There are some sparks there, but at the same time, one should not get over enthusiastic. So there are major mechanistic differences. The term neural network even is a bit over the top because LLMs and neural networks really perform very different computations from the human brain, particularly learning, what we do in neural networks. Backpropagation, there's no biological evidence that that's what happens in biological systems. Also, neural networks in computers are completely synchronous, so they propagate information step by step, whereas in biological systems it's real-time asynchronous. So yeah, one should not get overexcited. It's also anyway unclear what intelligence we are after. So I can very much recommend this book here. It's already a bit older, The Most Human. That's some years back, if you've heard of the Turing test, which is about building AI systems which can stand a conversation like a human. This has been solved some years ago already. But so there was this competition, so there were AI systems participating, and they also needed human participants, so that the judges had actually a challenge to distinguish, are they chatting with a human or an AI system? And the AI systems were ranked by the human judges, how human they were, but also the humans were ranked by how human they were. And so the premise of this author here is he wanted to be the most human human. So the participant that's ranked highest in humanness. And it's an interesting philosophical journey. What makes a human more human than another one? It's already a bit dated. It's a few years old. Yeah, I can much recommend. And there's also this over-the-top discussion of LLMs and their risks. So will AGI take over the world soon and discover that climate change is better solved by having no humans here? Yeah, predictions are difficult, but in my view, there's definitely lots and lots of hyping and over-the-top things. So OpenAI had this very clever headline when I think GPT-2 was announced. They said we have such a cool system, we cannot release it because it's too strong. Of course, a few months later, they released it anyway. And if you look at it today, it's honestly rather pathetic. But yeah, clever marketing that they're doing. So I would agree with this more cynical stance. That's an eminent NLP researcher, Jörg Goldberg. He said, in the little time that we have left before AI is wiping us out, we will at least get self-driving cars for a little while. And yeah, sentiment is obvious. So self-driving cars are being talked about since 10 years. They were hyped 2015 or so. They're still not widespread out there. So let's not get worried too much about LLMs suddenly becoming a superhuman. And it may also sound like a conspiracy theory, but there is also some evidence that maybe this discussion of the far away risks helps to deflect from the risk we have today. So LMs discriminate, have biases, make errors, and so on. But by talking about the far away risks, maybe we get rid of the attention on the problems today. And this is just an example of common problems which we have today with LLMs. So it's a classic riddle where you have a farmer which needs to get some items over a river, can only carry 2 items across. So a wolf, a goat, a cabbage. And if you change this riddle just slightly, so the LLMs have seen this riddle 100 times on the internet. If you change it a little bit, they're completely overfitting and produce nonsense. I made the wolf vegetarian here and the model doesn't capture this. Or there are strange instances where you can take an LLM, give them some math problems and then add irrelevant content and suddenly the answer changes. Or there are strange effects about knowledge representation. So an LLM might know very well the name of Tom Cruise's mother. So his mother is Mary Lee Pfeiffer, but then if you ask who's Mary Lee Pfeiffer's son, which in a logical knowledge representation is just the inverse relation, then suddenly the LLM cannot access that knowledge. So these are black boxes, not really scrutable, and that's not enough to advance AI. So we both need the symbolic, the knowledge graphs, and the neural side, the LLMs. Okay, so much about the setting the stage for AI knowledge. Questions, comments at this point? Yes?
Maybe it's a little distracting, but how do LLMs start ich finde das Wort zu halluzinieren, ja, to hallucinate.
Yeah, hallucinations, that's a fundamental property of these models, because these are statistical models trained to continue given text. And there are attempts to make them hallucinate less, but in essence, it's a fundamental property of when you continue something. So these are machine learning models that generalize from what they have seen. And generalization is essentially always hallucination. So, the classic machine learning problem is you're given a description of a person, and you should decide, do they get a credit or not. So we have financial information, family information, neighborhood, all this discussion of biases and so on. And when a new person comes, which was not in the training data, you should make a prediction, loan or not loan. And this is in a way a hallucination, because it's a prediction where you don't know what's the value. And LMs are doing something similar on text, so they're predicting the next word given previous words, which fundamentally means giving something unknown, unseen before.
So they just think that because of the previous words, that is the next word, and but the hallucination is that it doesn't know if it's right or not. Like
Yeah.
it can be a false fact or something else. That's why we can't trust LLMs in this sense.
Yeah. Fundamentally, these are statistical models, so they're not really saying this is the next word,
Yeah.
but internally they're saying with 97% probability, this is the word that best fits what I've seen before. With 2%, it would be this other word. With 1% would be this other word. So inherently, they are statistical predictors.
And maybe to add something, you do not know what fits. If you have the information that Erich Kästner was born in Dresden, maybe other people were also born, but not in Dresden. And if the LLM fits to the category was born in, maybe Erich Kästner was born in Berlin. Yeah, because he was born. And you do not know what information the LLM gives back to you. If it is a category or a word or something like this.
Maybe one more perspective is to offer that often we also want hallucinations. So the many tasks, like summarize this email or write an invitation for the next general assembly meeting of the company, mean actually that we want the LLM to hallucinate likely content. Or
Yeah, but it's not always true, because if you want a summary, the summary can also be false or something that you need to know isn't image. That's also the problem on this part.
Yeah. Yeah, for us humans, there's a notion of this is a hallucinated fact or not in the summary. For the LLM, there's no notion of truth, it's all just probabilities. So I think it's a fundamental issue with LLMs that will not go away, because it's fundamental in the architecture.
I heard that they actually try to let them run more and have more data, but also they like talk to them frequently. Like when you talk to an LLM frequently, you can say, no, that's incorrect, do it again, or no, you can't say that, you need to say this and this, and that the hallucination goes down a little bit, because it has instant feedback what it needs.
Yeah, if you give feedback, you can revise and you make them correct.
No, in the system itself, that it has someone to talk that it hallucinates less.
Yeah, that's sometimes another term, reasoning models. Have someone heard that? So that's also called test time compute. So that basically means the LLM does more computations before outputting a result, which again probabilistically makes it more likely correct, but it does not fundamentally solve it. It's just a lower probability. Okay. Further questions, comments? No. Then let's talk about common sense knowledge. So one particular class of world knowledge for LLMs. And I'll start with an example of what LLMs do wrong without cultural common sense knowledge. So this is a prefix of a dialogue which I've given as a prompt to, I think, GPT-3 at that time. So it was short narrated, two people in intercultural setting. our meeting in Tokyo, and now they start a dialogue. And so John says, okay, the bill is 8,000 yen, okay, let me leave 10,000 there. And if you give this to ChatGPT, so it will again produce a most likely continuation based on its training data. So here it suggests that Kenji should reply, okay, that's a very generous tip you're giving here. Does anybody know what's bad about this suggested continuation? ChatGPT? What's inadequate or wrong? What's a cultural blunder that ChatGPT does here when it suggests to reply with? Yeah, that's a nice tip that you're leaving. Yeah.
And in Tokyo, there isn't common to give tips.
Exactly. Yeah. So in Japan, it's not customary to give tips. It can be even seen as an insult for the wait staff. So this indicates the LLM is not aware of the local customs in Japan. Or I give you another example here. A German is visiting a friend in Taipei to bring some gifts home. Let's plan a shopping trip to the local market. Let's go when it's most busy. The Germans suggest let's go at 2 p.m. ChatGPT says, okay, perfect, the market will be lively around that time. Unfortunately, again, this is totally culturally unaware. So Taipei and Taiwan in general are famous for their night markets. So at a night market, you definitely shouldn't go there at 2 p.m. Go there at night. And why are these cultural blunders happening? Well, it's maybe not surprising. So LLMs are predominantly trained on English language corpora. The internet is English dominated, so the common data sets for the web clue, web common crawl are over 50% English. Even for the non-English content, the Western content creators still dominate. So that's an unintentional bias which happens in the training of these models. Then there are also intentional factors contributing to LLMs being culturally unaware. In particular, there are often attempts to de-bias the corpora or to introduce fairnesses, so that an LLM should not give a different answer depending on whether the person is of a different nationality or gender and so on. And there's a difficult conflict that these LLM developers are facing here, so that the models should not exhibit discriminatory behavior, but on the other hand, they should have some cultural awareness. And there's also a third stage, the system prompt, where again you can instruct the model to not do stereotyping, and that's likely happening with the commercial providers. We don't know what ChatGPT exactly does. But so these are three different sources for why the model struggle with cultural knowledge. And this problem is well known. There's also a well-known way out, which is called retrieval augmented generation. So instead of just starting from the prompt, going to the model and getting an answer, we can have a step in between where we retrieve additional evidence. So additional text documents could be, for example, Wikipedia or Wikivoyage or something, which makes the model more aware of the cultural setting and then tailor responses better to the setting. This is actually the standard when you use an interface like ChatGPT. So there this RAG, it's called retrieval augmented generation, happens by default. So the model does a web search, finds relevant documents, and based on the documents, creates a better answer. However, it's not always easy to find cultural content. And if you do this live at runtime, you also lose control because the search is not steered by you. You don't know to which resource it goes. So the alternative is to have dedicated, static, pre-computed repositories of common sense knowledge. And this is actually a long work in AI. Already since the 1950s, people said, okay, we need to compile this knowledge. There have been inspiring attempts since the 1980s where people actually sat down and tried to write down all the world's knowledge in a machine-readable format. Notably a project called Psych in the US. But they quickly discovered it's not possible to write down all the knowledge, especially not in a machine-readable format. around the 2000s came a project called ConceptNet, where we used crowdsourcing. So not just a few experts, but now hundreds of volunteers together writing down this knowledge. Here you can see examples what this looks like. So this is for the concept elephant. These are statements that people wrote down. So, elephant can be looked at a circus in Africa, like a zoo or in India, or elephant has a trunk, tusks, 4 legs. But this human written and it's very idiosyncratic and non-systematic. So elephant is capable of carry a trunk, okay, but to lift a tree, isn't that almost the same thing? I don't know. Visit the grocery store, I don't even know what that means. Maybe that's an English idiom. The elephant in the Porzellanladen in German. It's a strange thing when humans try to write down knowledge. And so what we have tried is to automatically compile collections of common sense knowledge in a machine readable format. Introduced to your Candle, which is based on text documents, and Mango, which is based on LLMs, where we extract knowledge from the large language model itself. In each case, get you 100,000 of statements for different concepts or groups. So let me start from the output. What are we after? So we are after statements of this kind. So we're having cultural groups, for example, geolocation based, so for the country Germany, and for the cultural facet drinks. What can be said about drinks in Germany? Well, the stereotypical assertion is probably Oktoberfest, that's what the rest of the world knows us for. Or geolocation based East Asia. Tofu is a major ingredient there. Can also be occupation based, so what is typical about the clothing of lawyers, wear suits, or also about the behaviors of firefighters. What does a firefighter actually do? Obvious to you, not obvious to an AI system. So they sometimes run into buildings to save lives. And how can we compile a large set of these assertions? So we're using a pipeline-based approach where we're starting with a set of cultural groups, which we define ourselves, a set of large text corpus, so in particular using something called the C4 corpus from Google. The C4 stands for the Colossal Clean Crawled Corpus. It's a corpus of 365 million documents crawled from the web and extensively cleaned, because on the web there's so much noise and so on. And this corpus, we are basically identifying documents or passages which talk about a cultural group. Then we are identifying relevant statements. We identify which facet are they talking about. So is this about food or drink or behavior or clothing? Once you have a large set of statements, you often have redundancy, so many things meaning the same thing. So we need to cluster statements together. And then we need to define a ranking order. What are the most salient statements for a group? And in the end, we have our resource. And yeah, so I'll go step by step through this pipeline. The first step, the source discovery. So which documents from this millions of text documents, which ones talks about a group of interest? So geolocations, basically the countries, major religions. A list of 100 occupations also. So that actually use quite simple heuristics. So basically a string matching, so is one of the cultural groups there. So these are sentences which would be identified. Some of them are actually useful. So Vietnamese food generally use vegetables as a useful statement about the group. Something like USA, USA, USA is not that useful. At least it doesn't tell me much. So in the end, we need a lot of filters, which are again handcrafted rules. So too long or too short sentence are dropped, sentence with bad words are dropped, sentence without verbs like USA, USA are dropped, or sentence which convey personal information. So I ate Chinese food. That's nice for you, but that doesn't tell us anything about Chinese food. So there's no cultural information conveyed in there. We further do a classification to find out about which facet the statement talks. So for example, this is a supervised machine learning model which basically says, okay, this sentence likely talks about food, this sentence likely talks about clothing, this sentence doesn't talk about food, it doesn't talk about clothing, it doesn't matter for the cultural facets which we're considering here. So this way we can drop a huge number of sentences from the corpus. We are arriving with millions of these sentences, and many of them convey the same thing. So Vietnamese people usually eat with chopsticks. Vietnamese food eaten with chopsticks. In Vietnam, food eaten with chopsticks is more or less the same thing. And for that one can use again machine learning models that find basically out how to cluster these sentences together, so that we both get rid of too much redundancy and that we also get frequency signals, so what are the things commonly talked about. We have a consolidated set of sentences, now we can rank them, so we can just say what are things talked about most frequently, what are the most distinctive things. For example, if I tell you French people like food and drink, then that may be a true statement, but it's not very distinctive because many other nationalities in the world also like food and drink. So even if something is frequent, it's not necessarily distinctive. And we have different ways of scoring all these sentences. And so this is the actual output, so you can go to this website. Actually the link is outdated, but I have the correct link later on. And you can basically search by the domain, country, or profession, or another domain, by the cultural facet, by the actual group. And then you get a ranked list of statements you according to a text corpora from the internet. So what are the most salient things to tell about food in Germany? Oktoberfest ranks high-end bratwurst and currywurst and potato salad and so on. And there's not just one ranking, but there are different scores here, which allow to basically see what are the most frequent things. Yeah.
Isn't it common that the LLM has biases due to that? Because when you see that, that's typical German things, but it's also, we all know, that's typical Bavarian things, and not all of Germany does that. So because of that, it also has automatically the bias in.
Indeed. So all models are wrong, not some are useful. These are generalizations. So not every German likes beer, not every German likes music, not every German goes to Oktoberfest. These are absolutely generalizations. This is what the internet thinks about the Germans, not what the Germans truly are. And ontologically not easy to say what's actually the truth. Whenever you talk about a group of people, you're actually sure to say something that is wrong. So Brazilians like playing football. I'm sure there are some Brazilians which don't like to do that. Indeed, that's a fundamental problem of these generalizations. Okay, so actually we look also at the quality of these assertions. One way is to say, are they good or bad? Another question is to ask, are they better than what other resources have? So we are looking at 3 dimensions of quality. So we're asking random people, crowd workers, basically, is the assertion plausible? So is it generally true? It doesn't mean that it's true for everyone, not every Brazilian, but is it generally true? Is it common? So have you heard of this assertion before, or is it something exotic and distinctive? So does this assertion actually differentiate the group from others? Just that French people like food and drink is maybe plausible. I think I've also heard that French people like food and drink, but it's not something that makes them distinctive. So these are 3 different ways to look at the quality of assertions. And yeah, we are not finding so that the results we get are outstanding, but they are clearly better than what other resources there are so far. Yeah, there's no true or false, but there's a relative question. Yeah. Over that. Yeah, so much about extraction of text. Now, texts are a bit an old-fashioned way to extract information. Nowadays, of course, we can do everything with LLMs. And so we also asked the question here, can we build cultural common sense knowledge directly from the LLMs themselves by just prompting them? And yeah, so ideas we want to distill a high quality resource of cultural common sense knowledge. In the end, again, we get hundreds of thousands of assertions for 11,000 cultural groups, so it goes surprisingly to a long tail, so it goes far beyond the 200 or so countries in the world. And what we can show that we actually can improve the raw response of LLMs in this dialogue setting. So I showed this dialogues about the night market and about the tipping in Japan before. So we can improve the raw responses by adding the cultural knowledge, which also comes from the LLM. So it's seemingly cyclic. So we're using LLM knowledge to improve the outputs of LLMs. But it relates to this idea of reasoning models, so giving the model more information, even though it's coming from itself, giving it more computations to arrive at a better answer. Yes?
Isn't it common then that the model starts to freak out and they don't know how to respond anymore because it's already data that they have and they use and they even stronger?
It can happen, and there are strange examples, but generally it helps. It's actually, it sounds strange, but it's not that magic. So if you directly go to an LLM in a dialogue setting, what basically happens, it does very well defined 72 or 96 steps of computation, one after another, in the so-called layers of a neural network. So you have this well-defined set of 96 computations, and then you get the output. Now, if you add this knowledge which comes from the LLM, you basically increase the number of computations. Instead of 96, you're saying you have now 200 computations or so, and that means more complex mathematical formula are possible if you have more intermediate results. It's not guaranteed to help if the model really doesn't know it. If it doesn't know the birth date of my rabbit, then no matter how much compute I give to it, it will, with more compute it will still hallucinate or freak out. But if it in principle knows it, then more compute gives it more likelihood to retrieve it.
But isn't it difficult, for example, if something is wrong and you see that something is wrong, more difficult to make it right? Because the LLM already computed it and has it in its loop in it?
Not sure I see. So if you have less compute, if you have 96 computes, you can be wrong. If you have 200 steps of computation, you have more chance to correct it.
Ich meine jetzt im Endeffekt, wenn ein Fehler sich einschleicht, dass halt im Endeffekt dieser Fehler erst nicht auffällt, dass eben immer so weiterrechnet und im Endeffekt diesen Fehler will man dann korrigieren, aber es geht gar nicht mehr, weil das LLM das halt eh schon so gesagt im Hinterkopf hat. Also so oder so es mit einbeziehen wird. Dass halt da eher dann so gesagt so dadurch halt Probleme entstehen. Weil so gesagt immer wieder das Gleiche dem zu geben, hat er, also in meinem Kopf würde das halt keinen Sinn ergeben, weil es wahrscheinlich dann irgendwie Fehler zu stark replizieren würde oder anfangen würde, Fehler zu stark zu replizieren.
Schwer zu, also vielleicht eine Analogie wäre, wenn ich hier zwei 10-stellige Zahlen hinschreibe und bitte addieren Sie diese zwei zehnstelligen Zahlen und Sie dürfen 5 Zwischenergebnisse aufschreiben oder Sie dürfen 10 Zwischenergebnisse aufschreiben. Mit mehr Zwischenergebnissen wird es leichter, das zu berechnen.
Also, dass so gesagt ein Fehler gar nicht sich so richtig einschleichen kann, weil so gesagt so dadurch, dass das so viele kleine Schritte sind, sich so gesagt das selbst wieder rausrechnet.
Ja, alles mit Wahrscheinlichkeiten. Ja. Okay, so knowledge extraction from LLMs themselves. What's our method? So the idea is, again, we start with so-called seeds. So we start with something. We define a few concepts where we're interested or knowledge about them. We define a few cultures where we're interested knowledge about them. So we just take cultures from a previous project. We take concepts from concept, the resource that I mentioned in the beginning. So where in the 1990s, people sat down and said, okay, what do we know about elephants? What do we know about airplanes? So with a small set of these seeds, we go with them to the LLM and ask the LLM, tell us what you know about this seed, what you know about this culture. This way we get some assertions. And with these assertions, we can go back to the LLM and get new cultures and new concepts. So it's basically a loop in which we in parallel discover more concepts and more cultures, and in the end we then get our we need to again perform clustering because there's many ways to say the same thing, and in the end then we have our consolidated resource from the LLM. And so how does this work step by step? So the assertion generation, we start with one concept, for example a dream catcher. We go to the LLM and we ask the LLM, give us cultural knowledge about dream catchers. So I might say, okay, for First Nations in Canada, dream catchers are believed to protect against their dreams. On the other hand, in Africa, dream catchers are not commonly used or recognized. So now we have 2 statements about dream catchers, but we've also discovered 2 new cultures in the First Nations in Canada and Africa. It's a very high level culture. But yeah, we have these 2, and now we can use the new culture First Nation of Canada and go again back to the LLM and ask it for new assertions for the First Nations in Canada. So if we start from a culture, so it's the symmetric case. Now, for example, if we start with Thailand, so if we ask the model, tell us cultural common sense knowledge about Thailand, it might say, okay, for Thailand I can tell you floating markets. They are actually a vibrant, popular place for buying and selling goods in Thailand. On the other hand, in Western countries, floating markets are not really known. They're something exotic only for tourists. Now we have discovered, starting from Thailand, a new concept, floating markets. Now we can also go with the concept floating markets back to the LLM and ask for further assertions. With basically 2 loops, how we can get from cultures to concepts and how we can get from concepts to cultures. And we can iterate them for as many rounds as we want in the hope that we discover more knowledge. These are the actual prompts that we use. So if you wonder what this looks like, it's really very basic. So we start with a concept here. So some chopsticks. So write culture specific common sense assertions. We give some examples. It's basically always contrastive examples. So car is important in the Western world, it's a luxury item in poorer countries. A few more examples. And then the LLM starts generating outputs as chopsticks in Japan common, in the Western world not common. The same we can do, instead of starting with a concept, we can do the same with a culture. So tell us things about Japan. So now we have another prompt for clustering. So we give it different statements and then ask, does this refer to the same or not? So please generate a representative sentence for the following assertion. So we give a set of these statements and then the LLM summarizes them. And this, for many iterations, so we actually start with with 30,000 concepts in the first stage, get 400,000 assertions. In the second stage, we get 10,000 new cultures, 115,000 assertions, and so we iterate this and iterate this. So each step costs you about $70 in API expenses, what you pay to OpenAI to be able to use their models at scale. But it's actually not a huge expense when you think of what it would be in work hours for a human to write down assertions. So in that sense, actually a quite cheap way. And the quality of the results is also quite good. So again, compared with the previous project, Candle. So if you look at it, so we have these 3 dimensions here: relevance, stereotype avoidance, linguistic accuracy. 0 is the worst, and 2 would be the best. So then in all dimensions, the result is actually better than the text extraction-based approach. It's still far from 2, so it's not perfect, but it's clearly better than what we can get from text. And yeah, what's in there? So these are the most common concepts for which we get statements. So family, hospitality, personal space, marriage, family structure. It looks quite sensible for a culture domain, I would say, but you have to judge it better than me. We get the countries or cultures for which you get most statements. So not surprisingly, US dominating. But we also get a quite interesting long tails for Amazonian tribes, 140 statements for them, or Inuit communities, 100 statements for them. So the model goes to a surprisingly long tail of statements. And this is what the actual output looks like. Again, you can find it on the website in Interactive Explorer. So for the culture in Japan, we have 4,600 statements with the most common terms in them. So tea, gift giving, names, hospitality, public transportation, punctuality, and so on. So these are just the concepts. And here are then the verbal statements. So, and indeed, matching the opening example, so the highest ranked statement here is about tipping. So tipping is not a common practice in Japan. Can be considered rude or impolite. And we've seen this a total of 74 times in different rephrasings. Personal space, highly valued, and so on. Now, here for Taiwan, we indeed see the night markets here. So night markets are vital to the local culture, center of street food, and so on. So for Taiwan, we have only 400 statements compared with the 4,000 for Japan, but it's a decent number of statements. And so this statement was seen 13 times, and we can also click and see what are the actual different phrasings of this statement. And, in natural language, there's many ways to say the same thing or similar things with different words. So there are minor variations here, all talking about the importance of night markets in Taiwan. Again, we did quantitative evaluations. The data is not perfect. These are common sense statements generalizing over cultures. But compared with other resources in cultural relevance and stereotype avoidance, this ranks highest, and in particular it also helps to improve dialogue. So overall, we get a 33% higher quality than if we don't use the knowledge, which is interesting because we are using LLM knowledge to help LLMs. It's a kind of cyclic thing, but it helps. So here's an illustration. So going back to the night market example, what we do is, what also ChatGPT does with its retrieval augmentation, we start with the prompt, so the prefix of the conversation, but then before directly generating the continuation, we basically insert in between the knowledge from our resource, which basically is a keyword-based retrieval, so local market. What do we know about markets? What we know, so night markets are vital, and then if we add this night market information, then ChatGPT gives a more culturally appropriate answer. So it says, hey, we'll go then in the afternoon. Let's go in the evening It's called night market for good reason. And yeah, so to summarize this part, mining cultural common sense from LLMs is possible. You need to think a lot about the prompt design, so we need actually many iterations until we have the right prompt to get out statements, because the LLMs are trained to not stereotype and are reluctant to give you this knowledge. So we get a resource which is of higher quality than a text extraction. However, we are losing, compared with text extraction, we are losing the source. So in a text extraction approach, you can always say this comes from this and that website. In the LLM-based approach, all you can say is all these statements come from ChatGPT. But why ChatGPT generated them, we have no explanation. The cost is surprisingly low, $110. Yeah. Explore the resource and give us feedback. Yeah, and with that I want to mention some challenges or limitations. So first, the comparison of text versus LLMs I already mentioned. So LLMs give us more and also better quality. We have to say the comparison is a bit unfair because we don't know what commercial LLMs are trained on. So OpenAI is a secretive organization. They don't release what data they trained on. If you knew what data they trained on, maybe if we were extracting from there, we would get better results. But as it stands now, commercial LLM versus open source text corpus LLM wins. LLMs can generate much more because it's a machine learning model which induces knowledge or interpolates, so generalizes. And the LLM extraction is also simpler than a text extraction. The text extraction actually was a quite complex process because you need to do a lot of rules, filtering, edge cases, which easier. But where the LLM loses is the ability to trace the statements back. So we don't have any source link. Inherently in LLMs, there's no way to link outputs to training data, even if it wasn't OpenAI, even if it's an open source model. And this is especially important because we are in a cultural domain and stereotyping, so where it's sensitive, where it would be good to trace back where the statements come from. And I already mentioned the English language bias, so it's not clear actually whose worldview we are capturing. Is this the view of the internet, or the Western internet, or the English internet? We are prompting the model in English. Is the progressive young people which are represented here, or whose worldview actually do these statements express? So, Oktoberfest. Actually, traveling internationally, I'm also surprised how people associate Germany with Oktoberfest. I've been there once. I didn't wear any lederhosen in my life, but it's the view of some other people about these cultures, not the view of the people inside the culture. And a related issue is the offensiveness. So we have in the human annotation this category. So do you consider the statement offensive? And there we're actually good. Less than 1% of the statements are considered really offensive. But straight back to a comment. So any statement that you make about a large group of people is somewhat wrong. There's this one view, all models are wrong, but some are useful. But there's the other view that whatever you write down, you might actually exacerbate the stereotypes, so reinforce them, and the next generation of LLMs are trained on this data again. We tried what little we can do, so hedge word phrasing, so not this is the truth, but this is what we extracted from the web and so on, but in the end it provides little protection. The data is on the web. Who can use it might not do appropriate hedging. And a fundamental problem is that it's a continuum between offensive and non-offensive, so it's not a binary thing. Joe mentioned these positive stereotypes. I actually had a friend from Brazil who was annoyed about everyone asking about football. So even positive stereotypes can be annoying. Yeah, so it's not clear how to handle this potential when we simplify generalized statements. And yeah, Issue number 3 is what do we miss? So we're extracting data from the LLM. The LLM is in turn trained on a filtered version of the internet. We extract it from a corpus C4, which is a filtered corpus from the internet. There's actually a very strange list there. The list of dirty, naughty, obscene, otherwise bad words that someone in the 2010s wrote down. If you have a strong mindset, take a look at this list. You find it with Google. Otherwise, better stay away from it. But someone wrote this down ad hoc, and since then everyone is using this list, but it's super ad hoc. And yeah, there are a lot of contents on the web which just by string matching contains words that are filtered out. So this is from the Bible here, and he said it is S. So when you do string-based matching, you get in problems of what you filter out, and it's intransparent, especially for the commercial LLMs. And it disproportionately affects minorities. So a lot of these verbs come from sexual minorities. And imagine an LLM which had never seen the word gay. What would the LLM behave like? So gay is not in this list, so, but the point is that filtering easily goes over the top and filters out too much content, which then means you have a blind spot in the LLM and you don't even know that, because for the commercial ones you don't even know what they're trained on. So we don't know what we don't know, the classic unknown unknowns. So yeah, what are open issues more on the technical side? So for the cultural groups, we typically have relations, hierarchies. So for example, Estonians or Baltic people or Europeans. These hierarchies could help to fill gaps, and they could also help to find interesting outliers. So for example, Hungarians, if I'm correct, are non-Indo-European language surrounded by Indo-European languages. So if one were to look at this distribution, one could get more interesting cases. But it's not easy because it's not one hierarchy, but it's actually multi-hierarchy. It will also be interesting to combine this text extraction and then LLM-based extraction so that we get the benefits of both. So the generalization abilities of the LLMs, but the grounding ability of the text extraction so that we know where the statements come from. One could do that post hoc, for example, for extraction. And so far it was an ad hoc set of cultural groups, so basically countries, ethnicities, religions. But there are also a lot of other groups you can look at, for example, based on interest or based on age-related groups. And it might be interesting, what do LLMs know or believe, what is there on the web. And there are thesis topics available, so a short advertisement here if you're interested in this, both on the more technical side or more on the analysis side of these outputs. Please get in contact with me. And yeah, these are the main papers. So to summarize, LLMs are very good in conversing, but they lack cultural awareness. We can increase this cultural awareness by incorporating cultural common sense knowledge, which we put in a paradigm called RAG, Retrieval Augmented Generation. So basically find relevant content and edit in the prompt. One challenge with whose worldview do these statements actually convey? How can we do this at scale and quality? And how can we explain or trace back the statements that we compute? Yeah. Thank you. Open to questions.
Thank you so much. I would suggest that we stop the stream for the discussion, and then we are free. Yeah. If you are watching, we see you next time. See you.